One of the most important theorems or principles which is used to find the voltage or current through a given element in the entire network happens to be superposition principle. Now, what is the statement of this theorem? It states that the voltage across or current through an element in a linear circuit is the algebraic sum of the voltages across or the current through that element due to each independent source acting alone. Now, what does this mean? Now, let's assume that there are three sources S1, S2, S3 in the given circuit. Now, these sources can be voltage sources or they can be current sources, and I need to find, let's say, the voltage or current through a given resistor, through an element. Let's assume that it's a resistor. So let me call this as R1. Now, to find the voltage or current through R1, first consider S1. So we consider S1 and we neglect S2 and S3. Now, how do we neglect these two sources? If it is a voltage source, you replace it by a short circuit. If it is a current source, replace it by an open circuit, right? So let me repeat. How do we neglect these sources? If it is a voltage source, replace it by a short circuit. If it is a current source, replace it by an open circuit. Now find V1 or I1 through this resistor. Now next consider S2, and we have to neglect S1 and S3. Again, how do we neglect S1 and S3? If it's a voltage source, replace it by a short. If it's a current source, replace it by an open circuit. Find V2 or I2. Next, consider S3 and neglect S1 and S2. Again, find V3 or I3. That means in the problem, if they've asked to find the voltage across R1, I need to find V1, V2, V3. If you need to find the current flowing through R1, I need to find I1, I2, I3. Now, if we are asked to find the voltage across R1, what is the total voltage? It is nothing but V1 plus V2 plus V3. As mentioned here, it is nothing but the algebraic sum of the voltages. Or if you had to find the current flowing through this element R1, it is I1 plus I2 plus I3. So this is what superposition principle or theorem states. Now let's take a few problems and let us see how we can apply this superposition theorem to find either the voltage or current through a given element in the entire network. So given this circuit, we need to find the voltage across this 4 ohm resistor using superposition theorem. Now what is V? V is nothing but V1. So let V1 be the voltage across 4 ohms because of 6 volts. So this is because of 6 volts. Plus let V2 be the voltage across the 4 ohm resistor because of 3 amperes. So first we need to find V1 and then we have to find V2. To find V1, as I've already mentioned, using superposition theorem to find V1, I have to neglect the other source. So here this happens to be a current source. So to find V1, 3A has to be neglected. So how do you neglect 3A? This is a current source. So this has to be replaced by an open circuit. So what happens to the circuit? The circuit changes. So we have plus minus 6 volts. There is 8 ohms and you have 4. And this is V1. And this current source has been replaced by an open circuit. So let the current flowing through the circuit be I1. So V1 is I1 into 4. Let's find I1. What is I1? I1 is voltage, which is 6, divided by the sum of the resistors, which is 8 plus 4, which is 12. So 6 by 12 gives 0.5 amperes. So this is I1. So V1 is I1, which is 0.5 into 4, which gives 2 volts. So V1 is 2 volts. So plus minus V1 equals 2. So this is what I've got. Now let us try to find the voltage across 4 ohms. by considering the current source 3 amperes. So to find V2, 6 volts is now replaced by a short circuit. So let me redraw the circuit. So you have 8, this is a short, again 4, and then you have the current source 3 amperes. This is 4 ohms, this is 8 ohms, and this voltage is V2. So I need to find V2. So what is V2? V2 is nothing but the current flowing through 4 ohms into 4, isn't it? So let this current be I2, and this gets divided as I3 and I4. So now we first have to find I4. What is I4? I4 is total current 3 into resistance of the other branch, which is 8, divided by the sum of the resistances 8 plus 4. So this is 24 divided by 12, which is 2 amperes. And we know that V2 is 4 into I4. So V2 is 4 into 2, which is 8 volts. So finally, what is the voltage across 4 ohms? The voltage V across 4 ohms is V1 plus V2. So we just have to find the algebraic sum of these two voltages, which is 2 plus 8 equals 10 volts. So this is how, by using superposition theorem, we can find the voltage V across a given element by considering one of these sources at a time. So let's take another example. Consider a circuit. We have to find the current through the 3 ohm resistor using superposition theorem. So we have to find I, which is nothing but I1. I1 is the current due to 12 volts. So this is due to 12 volts. Plus I2 is the current flowing through 3 ohms due to 24 volts. And I3 is the current flowing through 3 ohms due to the 3 ampere current source. So we have to consider one of these sources at a time. So first, let us consider the 12 volt source. So here I am considering 12 volts. So 24 is replaced by a short circuit and 3 amperes is replaced by an open circuit. So observe, 24 is replaced by a short circuit, and I have 8 ohm resistor here, and this is 3 ohms, and this current is I1. And of course, this is an open circuit because the current source is replaced by an open circuit. Now observe that these two resistors are in series, right? So these two are in series. So what is 4 plus 8? 4 plus 8 is going to be 12. So I replace these two resistors by an equivalent resistance, 4 plus 8, which is 12. So I have 12 ohms. Now observe, these two resistors are in parallel. So find the equivalent resistance. The equivalent resistance is, to find the equivalent resistance, multiply both the resistors divided by its sum. So you have 12 into 4 divided by 16. 4 4s are 16, 3s are, so you have 3 ohms. So this is replaced by 3 ohms. So the whole circuit gets simplified. So this is 3. So this is 3 ohms. So now I need to find the current I1. So it is the same current flowing through this 3 ohms as well as this 3 ohms. So what is I1? I1 is equal to 12 by the total resistance of the circuit, which is 6, which is 2 amperes. So I1 is 2 amperes. So you have 2 amperes plus. So now I need to find I2. So to find I2, what has to be done? I have to neglect 12 volts and also 3 amperes. So observe, the 12 volts is being shorted because I'm neglecting, and then you have 4 ohms and then 3 ohms here. So this is 4, this is 3, and then I only have to consider plus minus 24 volts. Then we have 8 ohms resistor, and then again you have 4 ohms, and then I'm neglecting this current source 3 amperes. So this is an open circuit. So again observe that 8 and 4 are in series, so they can be replaced by a single resistance, which is 8 plus 4 equal to 12. So you have 12 ohm resistor here. Now I need to find I2. I2 happens to be the current flowing through 3 ohm resistor. So in order to find I2, let me use loop analysis. So let this current IA be flowing in this network, and let IB be the current flowing in this loop. Okay, so I have IA and IB. So now we need to find I2. So let me consider these two loops here, and let me write the KVL in the first loop. So the total voltage 24 is equal to the voltage drop across 4 and the voltage drop across 12 ohms. So 24 equals 4 into IA is flowing in this direction, left to right, whereas IB is flowing in this direction, right to left. So the opposite. So IA minus IB plus 12 IA. So you have 24 equals 4 into 12, 4 plus 12 is 16, IA minus 4. So let me divide this entire equation by 4. So I get 6 equals 4 IA minus IB. So let me call this as equation 1. Now let me apply KVL to this loop. So we find that, again here observe, I have 3 IB plus, here IB is flowing from right to left, whereas IA is flowing from left to right, they oppose. So I have 4 into IB minus IA equals 0. So 4 plus 3 is 7 IB minus 4 IA equals 0. So 7 IB equals 4 IA. Or what is IA? IA is nothing but 7 by 4 IB. So this is 2. So substitute 2 in 1 for IA. What is IA? 7 by 4 IB. So let me do it here. 6 equals 4 into IA is 7 by 4 IB minus IB. So 4 gets cancelled. So you have 7 IB minus IB equals 6. So you have 6 equals 6 IB. So what is IB? IB equals 1 ampere. So observe that IB is the current flowing from the bottom to the top, whereas I2 is the current flowing from top to bottom. So these two currents are in opposition. So if IB is 1 ampere, I2 will be minus 1. So therefore I2 equals minus 1 ampere. So this is going to be minus 1 plus. Now I need to find the current through 3 ohms due to this source, due to the current source 3 amperes. To find the current I3, we have to short both the 12 volts and the 24 volts voltage source. So I replace it by a short circuit. You have 4 ohms and then 3 and then again 8, 4, and here you have a current source 3 amperes. So this is 3 ohms. I need to find I3. This is 4, this is 4, and this is 8. Now to find I3, let us use node analysis. So let this be V1 and let this be V2. Right, so this is 3 amperes. So this is the current. So let this current be capital I, which gets divided as IC and ID. So I have I, which is equal to 3 amperes, which gets divided as IC and ID. So 3 amperes equals IC plus ID. So what is I? I is IC plus ID. What is IC? V2 minus V1 divided by 4 plus ID. What is ID? ID is V2 minus 0. So this is of course grounded. V2 minus 0, which is V2 divided by 8. So we have I, which is 3 amperes, equals V2 by 4 plus V2 by 8 minus V1 by 4. So let me multiply the entire equation by 8 because I need to avoid these denominator values 4, 8 and 4. So 3 into 8 gives me 24 equals V2. So 8 by 4 is 2 plus 8 by 8 is 1. So you get V2 minus 8 by 4 is 2. So minus 2V1. So we get 24 equals 3V2 minus 2V1. So this is equation 1. Now observe this current IC gets divided as I3 and let me call this as IE. So this is IE. So we know that IC equals I3 plus IE. So what is IC? IC is V2 minus V1 by 4 equals. Now what is I3? I3 is V1 by 3. So it is V1 by 3 plus IE. So what is IE? V1 by 4. Right? So now observe here, V2 by 4 equals, I bring this minus V1 by 4 to the other side. So V1 by 4 plus V1 by 4 plus V1 by 3. So if I take the LCM, so it is 12. So you get 3V1 plus 3V1 plus 4V1 by 12. So this gives me 4 plus 3, 7. 10 V1 by 12 equals V2 by 4, right? So 4 3s are 12. So V2 equals 10 by 3 V1. So this is equation 2. So what do we observe? We have got a relation between V2 and V1. So V2 is 10 by 3 V1. Substitute this in equation 1. So 24 equals 3. What is V2? 10 by 3 V1 minus 2 V1. So 3 and 3 gets cancelled. 10 V1 minus 2 V1 is 8 V1 equals 24. So V1 equals 24 by 8, which is 3 volts. So now I need to find I3. What is I3? Very simple. I3 is V1 by 3. V1 by 3, which is 3 by 3 equals 1 ampere. So I have 1 ampere here. So you have 2 amperes minus 1 plus 1. 1 gets cancelled. So it is 2 amperes. So the total current flowing through this 3 ohm resistor due to this voltage source, the second voltage source and the third current source is 2 amperes. And we have found the value by using superposition theorem. So given any circuit, if you have multiple sources, voltage sources or current sources, we have to consider one at a time and then apply superposition theorem to find the voltage or current through any given element of the network. So this is how you do it. So if you have voltage sources, if the voltage sources have to be neglected, they have to be replaced by a short circuit, and if you have to neglect a current source, they have to be replaced by an open circuit. So we have taken 2 examples and we have seen how we can find the voltage in the previous example through a resistor using superposition theorem, and here in the second problem we have seen how we can find the current through 3 ohm resistor using superposition theorem. So it's a very simple concept. So keep practicing more and more problems, and do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads, and thanks for watching.